So, okay, chapter 4, part 1. Okay, so chapter 4 will be on pneumatic systems. Okay, before this, we have studied about individual components. So, pneumatic symbols, we have learned about pneumatic valve, pneumatic actuators. So, now we are entering to pneumatic system. Okay, system maksudnya is a combination. So, combination of all the pneumatic components to form one connection. So, we will start with single actuator circuit. Okay, single actuator circuit. What is single actuator circuit? I will explain along the way. Okay, so pneumatic circuit. What is pneumatic circuit? A pneumatic circuit is formed by various pneumatic components such as cylinder, direction control valve, flow control valve, pressure regulator, signal processing elements such as circle valve to pressure valve, and etc. So, meaning, so you can see here. All these elements, supply element, input element, processing element, control element, power element must be there. So jangan cakap, oh I put all the processing element there, so different processing element, I call it a system. Bukan. So it must start from supply and it will end with power. So dia kena ada 5 ni. So in exam biasa keluar soalan ni. So I explain 5 elements of pneumatic system. Okay, 5 elements of pneumatic system. So you can explain supply, input, processing, control and power in the sequence. So jangan campur-campur. Okay, so even today when you do the lab, so this week, so your circuit design, supply kena ada. So if you don't have supply, it's like you tak ada power untuk circuit. Like you don't have electricity, so you supply. Okay, so and supply element jangan letak dekat, lukis dekat atas, silinder dekat bawah. So itu ajaran Songsang. Okay, so follow the actual way, because the whole world, the engineers are drawing that way. So only you nak buat something baru, so you lukis terbalik, then no one can understand. Okay, so jangan jadi macam bahasa anjing dengan kucing kan. So must be able to communicate. So because in industry, so maybe you will work as an engineer in company A. So maybe 3 years. So you design a system, you lukis terbalik. So then you left the company, then another engineer come. So dia tengok, apa ni, benda tak betul. So don't lah. Tengok check balik. Student mana? Unimap. Aduh. Siapa ajar? So silent, mampoi lah. So jangan macam tu. So follow the steps of designing the pneumatic system. Okay, so the pneumatic circuit has the following function. Okay, the function of a pneumatic circuit is to control the entry and exit of compressed air in the linear rotary actuators. Okay, so you want to start from compressed air until the actuators. Okay, it can be motor or cylinder. So normally in your case we will give cylinders, okay, which is linear. Okay, so you want to use one valve to control another valve, so that we call as a indirect controlling, so which we will study today. So you are using a valve, give input to control another valve, so that is what we call as a indirect controlling. Then you want to control the actuator or any other pneumatic devices. Okay, itu adalah fungsi pneumatic circuit. Okay, so ini I dah explain tadi. So your pneumatic circuit or your pneumatic system consists of supply element, input element, processing element, control element and power element. So if your circuit is simple, maybe processing element tak ada. So input, control, terus power. So it depends on the complexity of the circuit. But normally for your exam level, dia akan ada all these 5. Okay, so it won't be too simple unless the question is a simple design. Okay, so diagram structure for the allocation of device to signal flow. So boleh tengok. So the left hand side adalah pneumatic or hydraulics. So the later part we will study on the hydraulics. So now we are covering on pneumatics. So hydraulic simbol dia lebih kurang sama. So just belajar chapter 1 to chapter 5, you focus to understand, so automatically you will understand hydraulics. So simbol dia, the function, the cylinder, the construction almost lebih kurang sama, cuma ada sedikit benda yang berbeza. Okay, so pneumatic and hydraulic you can put as a one class. Okay, and on the right hand side is the electrical or the electronics. So tengok input elements. So input elements in pneumatic, you use switch, push button, limit switches, you have a sensors, program module, and in electrical you have switch, push button, linear switch, program module, sensors. So lebih kurang. Tapi cuma the mechanism inside will be different. And the processing element in pneumatic, kita ada directional control valve, we have non-return valve, pressure control valve. But in electric, you have contactors, you have relays, you have electronics electronic modules. And for the control, for pneumatic, we have a directional control valve. And for electrical, we have power contactors, transistor, thyristors. And for power components, in pneumatic, we have cylinders, motors, constructional units, and for electrical, so we have solenoid. Okay, so electrical part kita akan belajar sikit, one chapter, chapter number 6, kita akan belajar pasal electropneumatic. Okay, electropneumatic, we even have our one lab on that. Okay, so electropneumatic, so pneumatical system gabung dengan PLC. Okay, so PLC you all belajar kan? Sam ni. So you akan gabung dengan PLC. So meaning the input will be coming from electrical, tapi kerja yang buat tu adalah pneumatic. So we will have a electropneumatic. Okay, so process sequence description. Ini adalah satu lagi benda yang penting. Because you akan tengok, somehow you will see this in your exam. Okay, so the first thing adalah the method to describe the process sequence. So macam mana kamu nak make people understand. So how you want to design. Sebab design circuit tu adalah benda yang last. Before that, you have a few steps that you need to follow before you draw. Okay, so that is what we call as a process sequence. Okay, so kalau dekat sini tengok ada 8. Okay, simple narrative, positional sketch, boolean, motion diagram, functional diagram ataupun flowchart. Okay, displacement diagram, control chart control and function chart. Okay, so always I encourage, so you follow the SOP. So SOP untuk design. So kalau you follow the design SOP, so I can give whatever question you tahu macam mana nak buat. Maybe it will take a little bit of your time, but it will avoid a lot of confusion. Sebab ada ramai yang saya tengok your bekas your seniors, right? So apa yang saya selalu tengok, dia orang terus nak design. So they don't want to go through the steps. Dia terus dari step 1, step 2 dia skip, terus lompat ke step 3. So when you have that, you will have problem later. Okay, so I always encourage follow the sequence. So kita akan tengok one by one, all of this I will explain along the way. So what is simple narrative? Soalan yang biasa keluar, simple narrative. So boleh tengok. So narrative, apa tu narrative? So what is narrative? Narrative. Yeah. I cannot hear. Something that you narrate. Okay. So narrate adalah dalam bahasa Melayu adalah jalan cerita. So macam mana? So because you see this circuit, dia ada jalan cerita dia. So start from down until up. So you cakap lah. So mula-mula dari compressor, So you tekan push button 1, dia akan buat ni. So they will activate this cylinder, cylinder akan extend, retract. So that is jalan cerita. Okay, so simple narrative, kalau boleh tengok dekat sini. So push button is used to turn the conveyor belt, so until the end. Until the end. So you tulis je. Okay. So dalam exam biasa keluar benda ni, I will either bagi simple narrative, suruh you lukis circuit based on the narrative, ataupun saya bagi circuit, suruh you tulis narrative. Either saya bagi macam ni, suruh you lukis circuit, ataupun saya bagi circuit ni, suruh you narrate. So which one is easier? Saya bagi circuit, you suruh you narrate kan? So depends lah. So either way can be. Okay, either way can be. Okay, so you boleh tengok macam mana dia start. Okay, so kalau you ada banyak push button, so you name the push button. Push button A, push button B, push button C. So that when you narrate, you boleh gunakan nama yang spesifik. Kalau you letak push button, you ada 10 push button, I pun tak tahu push button mana yang you cakap. Okay, so make sure even your design today, this week punya lab, make sure you put the name. Dekat bawah tu you boleh edit. So make sure you put the name. Macam dekat sini tengok sensor 1, sensor 2, push button, conveyor A, conveyor B. So letaklah nama yang spesifik. So that is simple narrative. I think you boleh understand. Okay, and simple narrative is not in point form. So simple narrative dalam bentuk perenggan. Okay, so make sure you give in a paragraph. Okay, so simple narrative tengok. So dia ada step dia. So first, identify the input and output. So input adalah push button, sensor 1, timer, sensor 2, timer. So ada few input, and output adalah conveyor A and piston kalau solenoid. Okay, ini adalah contoh lah. Okay, and second step, simplify the narrative statement. So point 1, so push button turn on the conveyor A. So letak lukis, baru you tulis dalam perenggan. So simple narrative kena dalam perenggan. Okay. Okay, so that's the first one. Okay, second one, positional sketch. Sketch, apa maksud sketch? Dalam bahasa Melayu apa? Sketch. Lakaran. Okay, so lakaran maksudnya bukan tulisan. You need to lakar something. So you need to draw. Sketch, so tengok. So dalam exam boleh tak lukis macam ni? So kalau you lukis 2D, kadang-kadang tak nampak. So positional sketch selalunya boleh lah, 2D boleh, as long you boleh convey. So kalau ada orang dekat luar, dia tengok, dia boleh faham. So then 2D is accepted. Kalau tak, lukis 3D. So kalau macam ni, you tengok, so cylinder A dekat bawah, cylinder 2 dekat atas, so cylinder 1A, so 2A dekat atas. So kita tahu, so the conveyor ada dua, then so barang masuk dekat conveyor, stop dekat sini, cylinder 1A push, dia naik ke atas, dan cylinder 2A push masuk ke conveyor 2. So from the positional sketch, we can understand how the system work. Okay, so kita boleh tahu. So that is what we call as a positional sketch. Okay, so kalau dalam exam, so kalau you lukis, so as usual, so we'll get marks lah. Okay, so lukis tu pastikan lukis something yang saya boleh understand. So jangan lukis lakar habis, sampai tak ada arrow. Tengok dekat sini ada labeling. So make sure something that is understandable. Okay, so boolean. So third one adalah boolean. So apa tu boolean? Ingat lagi, boolean. Digital electronics. Ingat lagi. So boolean adalah 1 and 0. So gunakan 1 and 0 dalam circuit lah. Tapi yang ni saya tak ada contoh dia. And boolean so far tak pernah keluar dalam exam. Boolean ni dia move kepada digital. So I think you already understood what is boolean. So selalunya 1 adalah extend, so 0 adalah retract. Macam tu lah. So 1 and 0 kita gunakan boolean. Or we can use OR gate, AND gate, so macam tu. So we use a logical expression using gates. So gates memang pneumatic pun ada kan, OR gate, AND gate, dia gunakan gates. Okay, number 4 adalah motion diagram. Motion diagram pun biasa keluar. So motion diagram is combination of macam ni, contoh ni. So you have a positional sketch. Okay, so dari sketch ni siapa boleh explain? So what will be the first sequence dari sketch ni? Apa yang akan berlaku? Okay, so dekat sini ada objek. So objek ni dia guna simple mechanism. Macam mana dia akan load? Gravity. So simple mechanism guna gravity. So you tak perlu very complicated design. So even gunakan gravity. So that's why the knowledge of thermofluid is very important in pneumatic and also hydraulic. Okay, so dekat sini gunakan gravity. So apa yang akan berlaku? First, what will happen? So A will push. So dia akan push, extend fully until barang ni sampai. So cylinder A kena ada sensor untuk detect whether it extend fully or not. Kalau dia extend fully, sensor akan on. Sensor akan on. So barang dah sampai dekat sini. Then what will happen? B push. B push. So B push. Then barang akan masuk ke kotak. So maybe this is a packaging punya application. Okay, so you can see all this narrative dekat sini semua ada. Then motion diagram. So this is motion diagram. Okay, motion diagram. So you can see what is A plus, B plus, A minus, B minus. Ini adalah something yang selalu you akan gunakan. So this is your cylinder operation. A plus apa tu? A plus meaning cylinder extend. So kalau cylinder extend, kita letak plus. Kalau retract, kita letak minus. Okay. So A plus dengan A plus. So selalunya kalau ada A plus, ada A minus lah. So jangan you biarkan cylinder extend sampai air dia tak retract. So must have A plus, A minus, B plus, B minus. So A plus, B minus semua ni adalah cylinder operation. Then dekat atas ni motion diagram, we have switch condition. Switch condition maksudnya macam sensor. Kalau cylinder A fully extend, sensor on, baru the next sequence start. Macam tu. So macam dekat sini B0. Okay, so you can see here, this is cylinder A dengan cylinder B. Setiap cylinder ada dua sensor. So sensor satu adalah A0, sensor 2 adalah A1, sensor 3 adalah B0 dengan B1. Apa function A0 pada pendapat you? So what's the function of A0? Apa yang A0 akan buat? Apa yang dia akan detect? Jarak. Tak apalah, saya bagi tahu. Okay, so A0 dia akan detect the position of your cylinder. Kalau dia fully retract, A0 akan on. So dia akan check whether your cylinder fully extend ataupun halfway ataupun fully retracted. So kalau A0 on, maksudnya cylinder dia dah balik ke tempat asal. So dia dah balik tu, cylinder ni akan on. So A1, apa fungsi A1? Dia apa yang dia akan check? So it will check whether your cylinder fully extend ke tak. So if already fully extend 100%, so A1 akan on, A0 akan off. Okay. So kalau tengah-tengah, apa akan jadi dekat A0 dengan A1? Kalau tengah-tengah, so dua-dua akan jadi apa? Dia takkan menyala lah, sebab it's not fully retracted, fully extended. So dua-dua akan off. Okay, cylinder B pun sama. So A dengan B ni adalah nama silinder. Okay. So to differentiate nama silinder kita letak capital. So nama sensor kita letak smaller letter, lower case. So A0, A1. Okay, so all this kita sambung kita letak dekat motion diagram. Because motion diagram ada dua bahagian. So the first part adalah cylinder operation. The second part is your switch condition. Okay, so dekat sini, so you in order for cylinder A to extend, so what will be the condition? So you need to make sure cylinder B balik dulu. Okay, cylinder B balik dulu, baru dia akan start A plus. So A plus, so what will happen? Cylinder A dah fully extend, A1 akan on. So A1 akan on. So kalau A1 on, baru B plus. So B plus fully extend, B1 akan on. So B1 akan on, then cylinder A kena retract balik. So retract balik, A0 akan aktif. So A0 dah aktif, baru cylinder B akan retract. Cylinder B retract, dia akan start balik B0. So it will complete one cycle, it will start balik. Faham tak? Tak faham? Confusing? Okay, tak apa, saya explain. Okay, so dekat sini ada dua cylinder. So two cylinder. So normally your whatever case that is given to you, it will be either two cylinder ataupun three cylinder. Okay, for your exam. Okay, so if three cylinder, cylinder A, cylinder B, cylinder C. Okay, so the sensor will be A0, A1, B0, B1, C0, C1. Dia ada tiga. So that's the first thing you need to understand. Okay, so this sequencing, so based on dekat sini, so cylinder A extend, so dia akan push barang ni until here. So when this cylinder B akan start? Cylinder B akan start when cylinder A1 on. Cylinder A1 akan on waktu cylinder A dia fully extend. Kan? Dia tak ada sensor untuk check barang dekat sini ya. Sensor attached to the cylinder. Bukan at this bay. So always remember, itu adalah cylinder ni. So sequence yang tadi, cylinder A extend fully, A1 is on, baru cylinder A akan extend. Dia kena dekat sini, then what will happen? Cylinder A retract, cylinder B retract. Okay, so A plus, B plus, A minus, B minus. Faham tak? So untuk sequence ni, you can draw this in the motion diagram. So untuk cylinder A start, B0 kena on. So meaning cylinder B dah balik ke tempat asal. So that is your first condition. Yang ni ada dekat mana? So confirmation of all extended and retracted position are required. So dia letak macam tu. So okay, so cylinder B, so the condition of the circuit to start, B0 kena on. So meaning your cylinder B already balik ke tempat asal, baru dia boleh start sequence baru. Okay, so here the starting condition adalah B0. Okay, B0 dah on, then you start your cylinder A plus. So cylinder A extend. Cylinder A extend, dia akan on cylinder A1. So cylinder A1 on, dia akan extend cylinder B. Cylinder B extend, B1 akan aktif, dia akan on B1. So kalau B1 on, dia akan retract cylinder A minus. Okay, then A minus, so it will activate A0. So A0 akan activate B1. Okay, so sequencing, it follow the sequence. So kalau yang ni kalau A plus, B plus, A minus, B minus. So maybe ada certain sequence A plus, B plus, B minus, A minus. It depends on the question. That depends on the application. So maybe sekarang you tak nampak sangat, tapi nanti kalau you dah buat your lab in our future tutorial semua, you will get better understanding. Okay, then we have a function diagram. So function diagram sama macam motion diagram. So just the sequence you name it 1, 2, 3, 4. So function diagram more understandable lah compared to motion diagram. Tapi for your design we will use more on the motion diagram. Tapi kalau you nak gunakan function diagram pun boleh, as long it helps you with your circuit design. Okay, so function diagram you can either do like this, macam flowchart, ataupun you boleh buat macam ni. Okay, so I prefer like this lah, sebab you letak semua dalam gambar. So input and output are separated. So this is your sequence 1, 2, 3 and 4. So sequence 1 adalah A plus, sequence 2 adalah B plus, sequence 3 adalah A minus, sequence 4 adalah B minus. Yang ni depends on the previous case. There can be a case A plus, A minus, B plus, B minus, boleh juga. So A plus, B plus, B minus, A minus, boleh juga. So it depends on the application. Okay, and dekat sini you letak selepas sequence ni executed, what will be the sensor input, sensor mana yang akan on. So kalau A plus, so A extend, A1 akan on. So A1 letak dekat sini lah. So selepas A1 on, it will activate B plus. So B plus dah fully, cylinder B already extend, dia akan on B1. So until the end. So selepas dah habis, so it will start back, it will go back. So it will sequence, this sequence will continue. So kalau you lukis macam ni, you letak dekat tepi lah. So it's actually the same. So just sensor tu you letak dekat tepi. So ST meaning start again ataupun stop lah, stop then start again. Sebab itu dekat sini dia macam go back, the arrow go back. So similar here pun sama. So it will go, then it will start back 0, 0, B0, B0. Okay, then we have a displacement diagram. So what is displacement diagram? Displacement diagram pun biasa keluar soalan ni. Okay, biasa keluar. So displacement diagram we have two. One we have step, displacement step diagram or displacement time diagram. Sebab kenapa step, I think biasa you tengok. So kalau cylinder extend, tadi kita tahu kan ada sequence 1, sequence 2, sequence 3, sequence 4. So sequence 1 until you lukis dekat atas. So 1A dengan 2A ni apa? So what is 1A and 2A? Apa tu 1A dengan 2A? 1A and 2A. So 1A adalah nama silinder, kan? Maybe dekat sini tak letak lah. So itu saya cakap kena namakan. So 1A dengan 2A ni adalah nama silinder. Okay, cylinder 1 and cylinder 2. Okay, cylinder 1 and cylinder 2. So yang ni adalah sequencing. So based on this step diagram, cylinder mana yang extend dulu? Okay, 1A extend dulu, kemudian dia maintain. So kalau dekat atas ni dia maintain, kemudian dia retract, dia maintain. Okay, so first sequence cylinder mana extend? So 1A extend. Second sequence, so 2A extend. Third one, 1A retract, kemudian 2A retract. So itu adalah step lah. So step by step. So you lukis dalam displacement step diagram. So yang displacement time diagram ni, so maybe dalam your circuit dia ada masa. Maybe cylinder A extend 5 second. Cylinder B 2 second. So depends on that you letak sequencing jarak dia. Kalau jarak banyak, so meaning so it's a longer period. So dekat sini you letak second lah dekat bawah ni. Ke bawah ni 1 second, 2 second, 3 second. So this is based on kalau solan tu ada pneumatic timer. Ataupun time delay valve. So kadang-kadang ada solan dia letak just cylinder is extended for 2 second then retract. So you boleh letak lah time. Selalunya dalam exam kita gunakan step je. Tapi kalau soalan tu suruh lukis compare dua-dua, so then you can compare. Okay, so you can see here. So this is your motion diagram. So motion diagram you boleh gabungkan dalam your displacement step diagram. So you boleh gabungkan. Tengok selalunya displacement step diagram cuma ada A plus, A minus, B plus, B minus. So dekat sini you letak juga your sensor. So A plus, so dia akan activate A1. So A1 akan activate B plus. So B plus akan activate B1. So macam tu lah. So you can gabungkan. Boleh gabungkan dengan your motion diagram. So all these charts, all these diagrams are to help you with your circuit design. Sebab itu kalau you tengok je terus nak design, so if you are pro then maybe can lah. So that one also if you don't do mistake. Dalam exam dah lah tak cukup masa, then you want to avoid mistakes. So that's why I say follow the steps. Okay, it will be easier for you. Okay, then we have a control chart. So control chart sama macam function diagram and all the other diagram. So yang ni dia cuma ada activated ataupun inactivated. So yang ni mostly for the cylinder or the sensors. So 1V, so adalah first valve, second valve, switch 1. So nama ni nama yang you letak lah. So if A lah. So jangan follow yang ni. So this is not standard. Ini adalah nama. So whatever component yang you letak nama. So if you letak AA, so letak dekat sini AA lah. So ataupun you nak letak nama you pun boleh. So just change. But for control chart, it will have open and also close. Open maksudnya ada input. So close maksudnya no input. So you can see. So let's say your cylinder A extend. Yang ni dia you letak dekat atas. You draw dekat atas. Okay, so based on this sequence ada 3 benda. Ada valve 1, valve 2 and also sensor 1. So from first sequence, apa yang aktif? Apa yang on? Valve 1 or 1V. So boleh cakap 1V lah. So 1V. So second sequence, apa yang akan on? Okay, 2V on. Sensor 1 on. 1V pun on. Semua on. Okay. Okay, third sequence, apa yang on? Okay, 2V on. 1V off. 1S1 off. Okay, fourth one. Semua off. Kan? Yang sequence ni. Semua off. So meaning semua tak ada power. So not actuated. Okay, so that's how you draw the control chart. Then we have a function diagram. Okay, the last one is combination of step diagram dengan control chart. So you gunakan apa yang convenient for you lah. So you tak perlu gunakan semua 8. Okay. So unless the question is saying specifically, so give a narration, simple narrative. Then you kena gunakan simple narrative. Ataupun you gunakan in your circuit design. So So use whatever. So function diagram ke ataupun motion diagram ke, so whichever things that can give you convenience in designing. So baca dekat sini function diagram, it has a step diagram and also control chart. Okay, so ada soalan so far? Ada apa-apa yang tak faham? So if tak faham tu, I think better you listen back, try to relate. Maybe I'm explaining in a very short period. So you try to listen back. Selalu saya akan bagi video. Yeah. Yeah. This one, the motion diagram. So normally, so motion diagram, it will be accompanied with another chart. So we will have a simple narrative, we will have a positional sketch, and maybe you can draw a function diagram or motion diagram to show the movement of the cylinders. Selalunya dia akan campur lah. Okay, campur one or two things. Okay, ada soalan lain? Okay, so summary of procedure to develop a pneumatic system. Slide ni adalah penting because you need to understand all these things before designing a circuit. Okay, so you need to understand the problem by considering the type and quantity of the component based on process sequence, input and output. So sebelum you design, you kena tahu komponen apa yang you nak pakai. Berapa banyak silinder diperlukan, berapa banyak valve diperlukan, seberapa banyak push button diperlukan. So you need to know all that things. So that's first thing. Then you need to know how many process are there. So macam tadi, sequence 1, sequence 2, sequence 3. So all that are process. Berapa banyak proses yang ada. Okay, and normally all these process will be interlinked. So satu sensor on, it will activate another sequence. Then it will activate another sequence. Sampai the sensor is on, the sequence will not be executed. Okay, then we need to identify the method to start the circuit. So circuit selalunya kita akan ada something manual. So that's the part of the operator lah. Operator selalunya akan start the button, baru your automation akan buat semua benda kan. So similar. So how you want to start the circuit? Either push button ataupun foot pedal ataupun hand lever. So apa-apalah. So apa-apa yang diperlukan. Then the method to stop the operation. How you want to stop? So ada emergency button ke, ataupun you need to after one complete cycle dia stop until you press the push button again. So you kena determine. Okay, draw the cylinder and directional control valve horizontally. Yang ini satu lagi. So macam circuit ni. So yang cylinder and all the valve, dia horizontal ke vertical? Dia mendatar ke menegak? Yang ni. Yang valve vertical macam ni. Cylinder macam ni kan? Silinder dia macam ni kan. So apa-apa simbol yang lukis, make sure lukis macam ni, flat. So jangan tiba-tiba satu simbol macam ni. So I kena pusing kepala untuk tengok. So always draw everything horizontally. So itu yang dia bagi tahu dekat sini lah. So that is what is mentioned here. Draw the cylinder and direction control valve horizontally. Semua flat. Okay, so that you can understand. So jangan tiba-tiba lukis straight. So it will be confusing. Okay, the energy flow within the circuit move from bottom to top. Okay, so compressor dekat bawah, jangan lukis compressor dekat atas. So dari bawah naik ke atas. Okay, energy source can be shown in simplified form. So energy source, you tak perlu lukis compressor, then filter, regulator, lubricator, baru masuk ke circuit. So you boleh just lukis this circuit, this line, this triangle. So triangle ni, so I already understood that you already providing a compressor. So tak perlu lukis all that. Okay, then show elements the normal position of the control. So normal position, you tahu unactuated position. So then kita tahu what is actuated. So draw a pipeline straight without crossover wherever possible. So garisan yang you lukis tu, so make sure jangan bengkok-bengkok, jangan free end, gunakan pembaris. So kalau free end, ada juga I tengok last year punya batch free end, so masuk macam ni circuit. Aku tengok pergi mana ni circuit. So make sure you use ruler. So bawa pembaris lah. Kalau you lupa bawa pembaris, you ada matrix card kan waktu exam, use your matrix card. So don't, because I will be marking all the 100 plus students punya answer sheet and all five question each. So I will be very fast. So kalau I tengok your circuit is complicated, I terus bagi kosong. So I just go for the next question. I just minus mark because it's not following the SOP. So don't make my life easy lah. So it's okay to make my life hard, but as long you know. Okay, so that's one thing. So use solid line for power lines or dash line for pivot. So yang ni along the way I will beritahu lah apa tu. Okay, so type of pneumatic circuit. So I'll try to finish up this slide so that we don't need to have class on Friday. Okay, so type of a pneumatic circuit. Okay, so macam mana nak activate the circuit? So there are two types. Yang ni pun soalan yang biasa keluar. Okay, so direct control and indirect control. So what is direct control? What is indirect control? So direct control adalah something yang very easy to understand. Sebab you tekan push button, terus dia on. Okay, so the simplest level of control for single and double acting cylinder involve direct control. So you don't have direct control, meaning you don't have any intermediate switching in between. So maksudnya you tekan push button, so dia akan pergi activate one valve, then that valve will activate the cylinder. Dia tak ada in between, tak ada apa-apa valve, straight away. Okay, so boleh tengok dekat sini gambar ni. So this is a direct control of single actuating cylinder. Macam mana saya tahu yang ni adalah single actuation cylinder? Macam mana saya tahu yang ni adalah single actuation cylinder? Cuma ada satu port, kemudian ada apa? Ada spring. Kalau nampak spring, you tahu itu adalah single acting cylinder. So maksudnya dekat sini you hanya perlu bagi compressed air untuk dia extend, balik itu gunakan spring. Okay, so what is direct control of single acting cylinder? So you press the push button, it will straight away connected to the cylinder. So meaning in between tak ada another valve. So it's direct. So normally it will be in normal position macam ni. So pressure masuk is disconnected, it will be at the retractor position. You press the push button, so dia akan ubah, and from compressor dia akan masuk ke cylinder, and cylinder akan extend. So that is what we call as a direct control of single acting cylinder. Ini adalah paling basic, circuit yang paling basic. Okay, circuit yang paling basic. So dia tak ada anything, so it's very basic lah. So you can see this example. Ini adalah soalan, mirip soalan yang keluar dekat exam. So dia akan bagi narrative, dia akan bagi gambar. Okay, a single acting cylinder of 25 mm diameter is to clamp a component when a push button is pressed. As long as the push button is activated, the cylinder is to remain in the clamp position. If the push button is released, the clamp is retracted. So you tahu yang ni adalah single acting cylinder dengan direct control. So you press the push button, cylinder akan extend, clamp. So you lepas the push button, dia akan balik. Okay, so circuit dia macam ni. So you So 1Z, 0Z and 0S adalah safety button. Okay, so from compressor. So you have a safety button to disconnect the circuit in case of emergency. So dalam exam saya encourage to draw this lah, dua ni. So that it will be better circuit rather than you just look at this triangle. Okay, so you boleh tengok. So this is a single acting cylinder and this is your push button. In between tak ada apa-apa, so it's a direct control. So you tekan the push button, yang ni akan pindah ke initial position. So udara akan masuk ke cylinder akan extend. So you lepas, yang ni dibalik ke sini because ada spring. Then yang ni akan disconnected, udara tak masuk, cylinder pun retract. So this is the solution for this. Okay, so faham? Single acting cylinder, direct method. Faham kan? Okay, so I think that's a easier one lah. So what is indirect control of single acting cylinder? So single acting cylinder still sama, cuma ada satu port, ada spring dalam tu. But what is indirect control? So you boleh baca lah sequence ni. So I just explain straight to this. Tengok, compared to direct method, apa perbezaan circuit ni? So what is the difference between direct method? Apa yang ada dekat circuit ni? Compare dengan direct tadi macam ni kan? So this is direct. Press the push button, terus connect to cylinder, extend ataupun retract. So what is different here in indirect control? Safety. Tak ada safety dekat sini sebab dia ni terus tadi compressor. So indirect, apa tu indirect? Indirect, apa maksud indirect? Tak direct. Indirect tak direct, betul lah. So I think you understood lah. So tak direct. So tadi direct dari push button terus connect to cylinder. Yang ni is indirect sebab dia masuk ke valve dulu. Valve dia baru control the cylinder. So indirect. So that is what we call indirect. So dalam indirect, in between akan ada another valve. In between akan ada intermediate valve. Kita panggil as intermediate valve. Ada tak perkataan tu? Tapi kesimpulan dia macam tu lah. So in between we'll have a intermediate valve to control the actuator. So dekat sini you tekan. So initially it will be like this, normal position. So push button is not push, so it's disconnected. Cylinder will be at a retractor position. So you press the push button, apa yang dia akan berlaku? Dari normal position dia change ke initial position. So dekat sini dia akan bagi input ke the valve, the cylinder valve. So yang ni dia akan tukar and your cylinder akan extend. So balik tu, so you disconnect, dia akan jadi macam ni lah circuit tu. So cylinder akan retract balik. Okay, so you can see an example. A single acting cylinder with a large piston diameter is to climb a workpiece following actuation of push button. The cylinder is to retract once the push button is released. Condition dia sama. So condition dia sama. So but you can design using direct method ataupun indirect method. So kalau direct method you are very confident with your circuit design, so you can go for indirect method. So indirect method dia ada advantage dia. So you boleh baca dekat sini. Okay. So it's suitable for large single cylinder with operating high speed. So you boleh control the speed. So you boleh ada more control lah. So that's why we have indirect method. Okay. So you boleh tengok how the circuit is designed using indirect method. So yang ni 0Z dengan 0S safety. So you ada push button dekat sini. So dia masuk ke the 3/2 valve and it will be connected to your cylinder. So you press the push button, yang ni dia akan ubah ke initial position. So it will give input to the cylinder Yang ni dia akan ubah ke initial position and it will activate the cylinder. So you lepas yang ni, so because of the spring, dia akan pindah balik ke your normal position and it will disconnect this, and because of disconnection, your cylinder akan retract balik. Okay. So kalau saya bagi soalan direct dengan indirect boleh buat. Untuk single acting boleh buat lah. So then we have for double acting, which I will explain dalam video at puzzle. I think that's all for today. So any question? Ada soalan? Okay, so kalau tak ada soalan, can off the video.